All right, let's continue working through the review, starting on number 15. 15 through 18, we're asked to find the sum or difference. Remember we talked about in class that we want to make sure that we look between the polynomials and see if it's asking us to find a sum, addition, or difference, which is subtraction. On the test, it won't tell you specifically which is which, so we just need to identify that by looking there in the middle. So this one would be addition. So that means that we're just combining like terms. So we take 3a, which is a like term to this a, and we combine those. So if I have 3a plus another a, I get 4a, and then 7 and negative 1. 7 minus 1 would be a positive 6. Next one, also addition. So we look for our like terms. Notice we have an x squared here and a 2x squared. So if we add those together, we get 3x squared. We have a 6x that doesn't combine with anyone else because there are no other x terms. So we get 6x, and then we have a negative 5 and a positive 15. When we add those together, we get a positive 10. Okay. Subtraction, remember we just take care of the negative first. So remember the negative changes the sign of the polynomial behind it. So this is going to be a negative m squared and a positive 5m. And then if we distribute that negative clear back here, we get a positive 2. And then we're just combining like terms. So again, we have a negative m squared here and a negative m squared here. That would make negative 2m squared. We have a plus or positive m here, plus 5m more would give us 6m. And then we have 2 on the end there and 2 on the other end, which add together to give us the 4 that would be at the end there. Notice it's in standard form when we finish, which you will be asked to do on your exam. The next one, again, subtraction, take care of that negative. So that's a negative 6p squared and negative 13p when we start to combine our like terms. So negative 6p squared doesn't have anyone to combine with, so we leave it as negative 6p squared. We've got a p value here, and subtract 13p would be negative 12p, and then that 7 that doesn't combine as well, bring up the end. Okay, addition and subtraction, make sure we're recognizing that. Multiplication then, we talked about distributing using FOIL or the box method. I'm going to do a couple of each. So on this first one, and I'm just going to rewrite this so that I can draw my arrows, we have a binomial times a binomial. So just remember that every term in the first polynomial has to distribute to each term in the second one. So first of all, the x, right? We go x times x, which gives us x squared. X times negative 4 is a negative 4x. We then multiply the second piece, the 6, to each piece over here. So we get 6 times x is 6x, and 6 times negative 4 is negative 24. Then if we can, we combine some terms. So notice both on the inside are x terms. So the x squared stays out front. Negative 4x plus 6x leaves us with a positive 2x. Subtract 24. Okay. If you like the box method, then on number 20, we could use that method. So just to review that one, we create a box, and we're doing a binomial times a binomial. So it's a 2 by 2. One of the polynomial's terms goes on the left, the other polynomial across the top. We then multiply to fill in the box. So we do y times y is y squared. Y times 8 would be 8y. On the bottom row, negative 5 times y is negative 5y. And negative 5 times 8 is negative 40. And notice again, we talked about the diagonal. Notice those are like terms, so when we pull that out, we're just going to have y squared. We combine those y terms, so 8y minus 5y is a positive 3y. And then we have our negative 40 on the end there. Again, notice it's in standard form when we finish. Number 21, so again, I'm going to go back to distribution. So again, if we're going to take this, we need to multiply him by each piece over here. So remember, x times x squared is actually x cubed, and x times 7x would be 7x squared. We then take the 4 and do the same thing, distributing them to each piece. we get plus 4x squared, and the 4 multiplied by 7x would be 28x. Combining like terms, if there are some, we notice both in the middle have x squareds, so we go x cubed, we combine the 7 and the 4 to get 11x squareds plus 28x. 22, again, let's try the box method. This time we have a binomial times a trinomial. So again, we'll have 2 rows, but then we'll have 3 columns for those terms. So here we're going to have negative 3y and a positive 1. Across the top, the other polynomial will have 4y squared, negative y, and negative 7. We multiply to fill it in. So negative 3y times 4y squared would be a negative 12, and y cubed. Negative 3y times a negative y, negative times a negative would be positive, and that's y squared. Negative 3y times negative 7 would be a positive 21, and it also has a y. Moving across the bottom, 1 times 4y squared is 4y squared. 1 times negative y is negative y, and 1 times negative 7 is negative 7. So looking at that again, notice that our diagonals hold those like terms, so we're going to combine those as we pull these out to create our polynomial. So negative 12y cubed comes out front, doesn't combine with any other terms. Our first diagonal, we have 4y squared plus 3y squared would give us a 7y squared. Negative y plus 21y is just plus 20y, and then that negative 7 is at the end there. Okay, and again you can apply any of those methods to work through these. Again, let's just distribute, so we get x squared here. X times negative 9 is negative 9x plus 9x. 9 times negative 9 is negative 81. Notice your middle terms, you have one negative 9x, one positive 9x, so those add to 0, leaving us just with x squared and a negative 81. Okay, same thing over here, we get 4y squared, then we get plus 8y. We keep distributing. Negative 4 times 2y is negative 8y, and negative 4 times 4 is negative 16. Again, those middle terms, you have one positive 8y, one negative 8y, they will add to 0, leaving us with 4y squared minus 16. The last ones, these are our square binomials. Remember, if we have a p plus 4 squared, that does not mean we can put the squared into all the terms. It means that there are 2 of these. So there's a p plus 4 and a p plus 4. Once you have them side by side, then we go ahead and multiply like we have been. P times p is p squared. P times 4 is 4p. 4 times p is 4p, and 4 times 4 is 16. We combine those middle pieces, leaving us with p squared plus 8p plus 16. Okay, again, last one very similar. That squared means that there are 2 of these, so negative 1 plus 2d multiplied by negative 1 plus 2d, and we go ahead and multiply that, so negative 1 times negative 1 is a positive 1. Negative 1 times 2d is a negative 2d. 2d times negative 1 again, negative 2d. And then notice at the end we get our 4d squared. We go ahead and combine the middle ones to get negative 4d. And we've still got 4d squared on that end and a 1 at the front. And then we would write it in standard form. So we're going to move that 4d squared to the front. Negative 4d still goes in the middle, and that positive 1 doesn't have a variable part, so it gets to go at the end. Again, on your test, you will be asked to perform the indicated operation, and you'll need to recognize whether it's addition, subtraction, or multiplication, and then perform that operation and write it in standard form. Moving to the back page, we're looking at 27 and 28. These are linear functions, and we're asked to find the slope, the y-intercept, and then write the equation for the line in slope-intercept form, which remember is y is equal to mx plus b, where m is your slope and B represents your y-intercept. So looking at the graph here, we find points where we can tell it's crossing at lattice points. So for example, right here, it looks like it's crossing at an intersection, and down here. So we would count, we move left to right, this guy goes down 2, and then it goes to the right 3. So our slope here, we would write as -2/3. Part B asks for the y-intercept. Notice here's our y-axis, and the line is crossing down here at -5, so we would write our y-intercept as -5, or the point 0, -5. And then our equation would look like y is equal to, we put our slope in, times x, subtract our y-intercept there. So there's our 3 pieces. Again, moving to the right, we look for points where it's crossing at a lattice point, so it looks like there and there. We move left to right, so I start at this left dot and I go up 2, and then I run 3. So we go rise over run, or 2/3 for our slope. The y-intercept in this case, it looks like, is crossing right here at a +3. So we've got 3 here, and our equation, if we put that all together, becomes 2/3 x plus 3. Okay. The last one is drawing the number system. So remember, you won't be asked to draw the number system per se on your final exam, but you will be asked to determine which sets values belong to. So it's important we understand and remember what those names and symbols are. So let's start with our number system. Again, this is the way the number line is built. We start with our natural numbers, and the sign for that was that n with the double bar on the left. Those are numbers like 1, 2, 3, and everything above that. Very positive, natural counting numbers. After that, we added in a 0, so we wanted that 0 place value. Those were called the whole numbers. So we used a W as the whole numbers. After that, we added in some negative values. So any of our negative values, negative 1, 0, 1, everything bigger, everything smaller, those were our integers. So we used a Z, right? They were called integers. After that, then we talked about fractional values. So we have values like 4/5, or a decimal value that ends nicely like 0.75. These we used a Q to symbolize the rational numbers. Outside of rational numbers, we have what we call irrational numbers. So irrational numbers, their symbol was a P, and they are numbers like decimals that never end, or pi is a very common one, or we said the square root of a value that doesn't give us a whole number output. Around these, our rational and irrational numbers, they make up what we call the real number system. So we put the real numbers with that R on this one, and you don't need to include an element necessarily. It's any of those rational or irrational numbers make up the real numbers. Outside here, we put this one in a cloud to help us remember. We call these imaginary numbers, and their symbol is that I. Imaginary numbers occur whenever we find a negative in our radical square root. So if we have the square root, we said of, say, -1, and the symbol for that is a little cursive I. So either of those is great. And then lastly, with imaginary numbers and real numbers, we create what we call the complex number system. So these are our complex numbers, and remember an example of that would be a real number, any real number, say 3, added or subtracted to an imaginary number like 10i. Okay, and there's our number system, so just make sure we're recognizing those symbols and recognizing what numerical values come from where. So for example, if you were asked where did the value, let's say 6 fit into this, we would come to this and say, well, 6 would fit into these natural numbers. So if it belongs to the natural numbers, they're inside the whole numbers, who is inside the integers, who is inside the rational, who's inside the real, which is inside the complex. So we would list each of those. The natural numbers belongs to the whole, belongs to the integers, the rational, and the real, and the complex. If we had a number like 3i, That guy is not a real number, so we have to start out in the imaginary, and it's only imaginary, and we could consider it complex as well. A number like the square root of 7. The square root of 7 would be an irrational number. Notice the irrational numbers here. They're inside the real numbers, who's inside the complex, so they only belong to the real and the complex. Again, a fractional value such as 2/3, that would belong in those that rational set. So we would start in Q, and then Q is inside of the real numbers, which is inside of the complex numbers. So we just want to make sure we understand that moving out. That's your review for your key, or the key for your review. So just kind of look through that and make sure we're comfortable with each of the parts of that review and the language used in asking each of the questions. Good luck.